Chapter 14, Acids and Bases. In Chapter 14, we will be discussing acids and bases, and in Lesson 14.1, we will be generally describing acids and bases. Firstly, acids. Where can acids be found? Acids are mainly found in day-to-day objects such as lemons, in the form of citric acid, and in some medications as well. Bases, on the other hand, are mainly found in cleaning products, but also can be found in medication in the form of antacids. The first person to formally recognize acids and bases was savant Arrhenius. His definition stated that when dissolved in water, acids release hydrogen ions, while bases release hydroxide ions. This definition is mainly not used today because it limits the reaction to be in an aqueous solution or dissolved in water. The second definition, which is more commonly used today, is the Bronsted and Lahey definition, which states that acids are H plus donors, while bases are H plus acceptors. This definition is most commonly used today because it is not limited to being dissolved in water. Using this definition, we also get conjugate bases, which is what is left of an acid after it loses its H plus ion, and conjugate acid, which is what is left of a base after it gains an H plus ion. Take, for example, this reaction below, where NH is considered the base because it goes from NH3 to NH4 plus. Here it is important to mention the plus since we are adding H plus ions, not H atoms. Water here is also considered an acid because it loses its H plus, going from H2O to OH minus. NH4 is considered a conjugate acid because it is what is left of NH3 after it gains a hydrogen ion. To find the strength of an acid, we would usually find the K value of said acid, which is the products over the reactants. Keep in mind that we always exclude water from this reaction, or from this equation. Also note that H3O plus in aqueous solutions is the same as H plus, because when the H plus ion is released, it is usually absorbed by water. In this question, they ask you to write the dissociation reaction for each of the following acids, omitting water, meaning water should not be included. So here we have HCl, which to become an acid has to release its H plus. So it becomes Cl minus and H plus. For acetic acid, we have HC2, H3O2. And keep in mind, here we remove the outermost hydrogen, since this one is incorporated into the compound. So this would become C2H3O2 minus plus H plus. In NH4 plus, when we remove the additional hydrogen, we will be left with NH3 neutral because the sign is taken by the hydrogen ion.
That'll be it for lesson 14.1, the nature of acids and bases. If you have any questions or want to ask anything at all, you can ask it down below in the comment section or in the server. If you want more tutorials like these, you can find them on the channel pages or on the server. And yeah, enjoy them.